This lesson is on the properties of exponents. I want to start out with a few examples. This says work with a partner, but we're just going to go through it together. This is in your student journal. So part A says, what happens when you multiply two powers with the same base? Write the product of the two powers as a single power. Then write a general rule for finding the product of two powers with the same base. So let's look at what that means. So here we have two powers with the same base. They both have a base of 2. 2 squared we know means 2 times 2. And 2 to the third, let's make that a multiplication sign, times 2 to the third times 2 times 2 times 2, which gives us 2 to the fifth. When we have 5 to the third times 5 to the fifth, we have 5 to the third, that's this part, and then we have times 5 to the fifth. 5 to the fifth. We have 8 5, so that's 5 to the 8th power. On this one we have 4 to the first, which is just 4, times 4 to the fifth. So 4 times 4 times 4 times 4 times 4. And we see we have 4 multiplied times itself 6 times. So 4 to the 6th. And then the last one, we switch from talking about numbers to talking about variables. X squared means x times x, x to the 6th. Looks like this. And we have 8 x's, so we have x to the 8th. So if we look at that and we look for the pattern, what can we see? What can we do with 2 and 3 to get 5? And with 3 and 5 to get 8. 5 and 1 to get 6. 2 and 6 to get 8. It seems that we are just adding the exponents, which is what our rule states. That instead of doing all of this work like this and writing it all out, we can say it's 2 to the 2 plus 3, which is 2 to the 5th. This one is 5 to the 3 plus 5, or 5 to the 8th. This is when we have two powers with the same base. So you'll notice you see the base written out twice each time that happens. That's one of the ways we know that that's the rule we're going to be looking at. For the second one, it says what happens when you divide two powers with the same base. So we're going to kind of switch direction here and talk about division. We've got 4 to the third divided by 4 squared. So 4 to the third divided by 4 squared in expanded form looks like this. And we know that we can cancel numerators and denominators since this is multiplication. So both of those cancel, leaving us with just 4, which we could say 4 to the first. We generally don't. On the next one, we have 2 to the fifth divided by 2 squared. Here we can see that we have 2 sets of 2's that cancel, leaving us with 2 to the third. On number 3, we've got x to the 6th on top and x to the third on the bottom. When we look at that, we can cancel 3 sets of x's. So that those all, when we cancel, we're saying those x divided by x is 1. So we have 1 times 1 times 1 times x times x times x. So x to the third. And then on this last one, 3 to the 4th divided by 3 to the 4th is just 1, because we know that anything divided by itself is 1. So since now we're looking for a general rule, let's look at our exponents. On the first one, we had 3 and 2 and got 1. On the third one, we had 6 and 3 and ended up with a 3. And on number 2, we had 2 and 5 and 2 and got 3. And if you look, you can see what's happening each time. We're just subtracting the exponents. 3 minus 2 is 1. 6 minus 3 is 3. And 5 minus 2 is 3. 4 minus 4 is 0. And we know 3 to the 0 power is 1, because anything to the 0 power is 1. So if we had x to the a over x to the b, we would subtract a minus b, and we would have x to the a minus b. Now in this section, we're looking at what happens when you find a power of a power. So this time you'll notice that our base, let me grab my highlighter here. You'll notice that your base is only written one time. When our base is only written once, but we have two exponents for it, that's when we're talking about a power of a power. So when we look at this first one, 2 squared to the 4th, if I write that in expanded form, it means 2 squared times itself 4 times. And that method that we just looked at said we just add those exponents. So we have 2 to the 8th. On number 2, we have 7 to the 3rd squared, which means 7 to the 3rd times 7 to the 3rd. 3 plus 3 is 6, so 7 to the 6th. Number 3, y to the 3rd cubed, as we multiply it times itself 3 times, and we get y to the 9th. And then for the last one, x to the 4th squared, x to the 4th times x to the 4th. 4 plus 4 is 8. But it can get tedious to always write those out in expanded form. So we want to look for what we're doing here. What is happening to 2 and 4 that gives us 8? What is happening to 3 and 3 that gives us 9? 3 and 2 that gives us 6. 4 and 2 that gives us 8. That's multiplication. So all we need to do when we're finding a power of a power is to multiply the exponents. You'll notice that in each case, the base number stays the same. So instead of doing all of that, we're going to do 2 to the 2 times 4, which is 2 to the 8th, and y to the 3 times 3, which is y to the 9th. In part D, we're looking for the power of a product. So you'll notice we have multiplication inside and an exponent on the outside. Here we have 2 times 5 and it's being squared. 6 times a is being squared. 5 times 4 is being taken to the 3rd power. 3x is being squared. So we're finding the power of a product. So when we do that, we're going to, everything that's inside is being taken to that power. 2 squared times 5 squared. 6 squared times a squared. 5 squared times cubed times 4 cubed. 3 squared times x squared. And then if the numbers are reasonable, we would go ahead and multiply them out. For example, here we could do 4 times 25 is 100. 6 squared is 36, so 36a squared. 3 squared is 9. 9 times x squared. What about the power of a quotient? So we know quotient is the answer to a division problem. So you'll notice each one of these involves division with a power on the outside of that set of parentheses. This is very similar to the power of a quotient in that both things inside get that power. So for 2 thirds to the 2nd is going to be 2 squared over 3 squared, 4 ninths. For number 3, we would do x cubed over 2 cubed, so x cubed over 8. 4 thirds to the 3rd would be 4 to the 3rd over 3 to the 3rd, so 64 over 27. And for the last one, we would have a to the 4th over b to the 4th. This gives us an example of a lot of the rules that we're going to be using in this lesson. Since we're at about 10 minutes, I'm going to go ahead and stop this one, and we'll start the next one talking about negative exponents and what happens when we have powers of 0.